Okay, so problem 1 asks us to find the values of x that solve the problem. Round to 2 decimal places if we need to, but use exact values as long as we can. Question 1 asks us to find the value of x closest to 0, for which y equals 6. With the function y equals 2 sine of the quantity of pi times the quantity of x minus 1 closed quantity plus 7. So the first thing that we're going to do is we're going to substitute the quantity of which sine is being taken of for alpha, and we're going to rewrite the function to be y equals 2 sine alpha plus 7. We can now solve to find what sine alpha would be equal to. So to do this, we're going to set this equation equal to 6 and solve for sine of alpha. So first thing we're going to do is subtract 7. We're going to have 2 sine of alpha is equal to -1, and then we're going to divide by 2, and we're going to have that sine of alpha is equal to -1/2. So we can now look at a unit circle or think about where -1/2 is the value for sine on the unit circle and draw that out. So if we have circle here, and we have here, we can look at the unit circle, which I have a picture of here, and we can see that in the we can see that sine is equal to -1/2 here because sine is a y value, and also here. So our values at these two places are going to be 7 pi over 6 and 11 pi over 6. So we can now draw these out on our new unit circle. And we're going to have here that over here is 7 pi over 6, and over here is 11 pi over 6. Okay, so now what we're going to do is we're going to take that alpha, and we're going to solve for alpha, and we're going to have that alpha is going to be equal to 7 pi over 6 plus 2 pi k, as well as 11 pi over 6 plus 2 pi k. And the 2 pi k is just because we can go around as many revolutions as we'd like. The k determines how many revolutions. Okay, so what we can now do is we're going to substitute in what alpha is equal to, which we know up here, this is alpha, is pi times x minus 1. So we're going to have pi times x minus 1 here is equal to this same thing, 7 pi over 6 and 11 pi over 6, both plus 2 pi k, sorry. So now we can remove pi from the equation by solving out pi, so we can divide by pi both sides. Same thing as multiplying by pi 1 over pi. So if we do this, we're going to get that x minus 1 is going to be equal to 7 over 6 plus 2k, and 11 over 6 plus 2k, right? Because when you divide by pi, you're going to get that this cancels and this cancels and this cancels, this cancels and this cancels, because you're going to distribute this to both and it's going to divide out. So then we have that x minus 1 is equal to 7 over 6 plus 2k and 11 over 6 plus 2k. We can now get rid of the -1, so we can add 1 to all sides. So 2k can stay the same because that's just counting the revolutions right now. But what we're going to get is that x is going to be equal to, and we're going to add 1 to 7 over 6. So 7 over 6 plus 1 is going to be the same thing as 7 over 6 plus 6 over 6. So we're going to get 13 over 6 plus 2k. And then for 11 over 6, it's gonna be plus 1, and that's the same thing as 11 over 6 plus 6 over 6. So we're gonna get 17 over 6 plus 2k. Let me bring this down here so we have some more room to work with. So we now have that these two values are what we have for x right now. And we can move k into the equation, or we can make k equivalent to the equation by finding a common denominator. So what we're going to do is that this is the same thing as 13 over 6 plus 12 over 6k, right? Because if we have to get 2k over the denominator of 6, we realize that we have to multiply everything by 6 over 6 because we can only multiply by 1. So we're going to get 12 over 6k, right? And we're also going to have 17 over 6. And plus, to get the same denominator over 6, we're also going to have 12 over 6k here because we're doing the same thing we did here. Then we have that x is going to equal to, for k equals 0, and then also for k equals -1. We're going to have that for k equals 0, where it would be 0 revolutions, and it would just be 13 over 6. And then k equals -1 is for a negative revolution, which would just be going this way. And for 0 revolutions, it would be going this way. So we're now going to have that k equals 0 is equal to 13 over 6, as well as 17 over 6. And k equals -1 is going to be 1 over 6 and 5 over 6. So in order to get these values here, what we do is we sub in for k. So when we have k is equal to 0, we're going to have 13 over 6 plus 12 over 6 times 0. So that's going to make this entire term go to 0. And then we're going to be left with 13 over 6, which is this value here. Then for k equals 0 for 17 over 6, we're going to have 17 over 6 plus 12 over 6 times 0 again. And this term is going to go to 0 again, and we're left with 17 over 6 here. So for k is equal to -1, we're going to have 17 over 6. Sorry, let me start with the first term. We're going to have 13 over 6 plus 12 over 6 times -1. And also for the second term, 17 over 6 plus 12 over 6 times -1 for k. So here, we're going to have this become 13 over 6 plus -12 over 6. And then here, we're going to have 17 over 6 minus, which we can make the plus minus into just a minus 12 over 6. So for the first one, we're going to have 13 over 6 minus 12 over 6 is going to give us 1/6. And then for this one here, we're going to have 17 over 6 minus 12 over 6 is going to give us 5/6. So then for these two values, this is what we get. We get 1 over 6 and 5 over 6. So now we're going to look at these values that we have for x, because that's what we've been looking for. And we're going to see which of these values is closest to 0, because that's what the question is asking for, right? We have up here, find the value of x closest to 0 for which y equals 6. So we're now going to have that 1/6 is the closest to 0 out of all of these numbers. So our x is going to be equal to 1/6, and this is going to be our answer. For some more information really quickly about why k equals 0 and k equals -1 were the chosen values that we decided to plug in for k. Since the 2 pi k term over here represents, or sorry, over here is going to represent the amount of revolutions that are added to our value. Our values are here, 7 pi over 6 and 11 pi over 6. For k equals 0, that means it's just our value of 7 pi over k. So we're only going to 7 pi over k, and we're not doing any extra revolutions. So k is equal to 0 because it's just our value, 7 pi over 6 plus 0, because we're not doing any extra revolutions. And this term here represents the number of extra revolutions. For k equals 1, we chose, or sorry, for k equals -1, we chose k equals -1 because instead of doing 0 revolutions, we're actually going backwards 1 entire revolution in addition to this part here, which is our 11 pi over 6. So what we're doing here is we have 11 pi over 6 plus -1 revolutions around the unit circle. Okay, so now we have question 2. You are aboard a submarine submerged in the Pacific Ocean. At time t equals 0, your submarine is discovered by an enemy destroyer ship, nearby ship. Your submarine starts porpoising, meaning the sub repeatedly goes deeper and then shallower in cycles. So it's going to be cyclical, like a sine function or cosine function. To try to avoid future detection by the enemy, at time t equals 4 minutes, your submarine is at its deepest, which is 1,000 meters below the surface of the water, -1,000 meters. So that's going to be our minimum. At time t equals 9 minutes, your submarine has reached shallowest depth, which is going to be our maximum, which is 200 meters below the surface of the water. So it's going to be -200 for that point. You know, the sub's distance from the surface of the water varies sinusoidally with time t. Once again, it's going to be a sine function or a cosine function. So 2a says to graph the sinusoidal function below, make sure to label important values on each axis. So these here in blue are our points that we got from the paragraph above. We have that at 4, our graph is gonna at time t equals 4, because the x-axis here is time and the y-axis here is height in meters, and this is time in minutes. So at time t equals 4 here, we're gonna be at -1,000 meters. So we're gonna come here at 4 down to 1,000 meters. We're gonna have a point here. Then at time t equals 9, we're going to be at -200 meters. So over here, we're going to have a point right here. We can now find the midpoint by finding the average between these 2 points. So we're going to have the max plus the min divided by 2. So we're going to do -1,000 plus -200 divided by 2. This is going to give us -600, and then it's also going to be the median, or the average between 4 and 9 for our time values. So we're going to have 4 plus 9 divided by 2, and that's going to give us 6.5. So where they're going to have here at 6.5, we're going to come down to -600. So we know that this point here is going to be our minimum, and this point here is going to be a maximum, and this point here is going to be our midpoint. We can then repeat these values because it's sinusoidal function and draw out the rest of the graph. So let me erase this here so we have some more room. So we're now going to be able to make the same point at 1.5 at -600. And then we're going to be able to make the same point at 0 for -200. And then we're going to be able to make the same point at 11.5 at -600, and so on at 14 for -1,000. So we can now draw out this graph. I'm going to do my best here. So generally, this is our value of the graph. The question 2b says to write 2 equations for the sinusoid using y as a dependent variable. One equation must be the positive cosine equation, while the second equation must be the positive sine equation. So to find equations, we have these points here, right? These first 2 are minimum and maximum given to us in the paragraph, and the second 2 are midpoints that we found using the average of the minimum and the maximum. So the first thing we're gonna do is we're gonna try to recognize the period. So to do that, we're gonna go back up to the function and we're gonna find where we can start with the sine function. So since the sine function crosses through the origin usually, we're gonna have our sine function start here at 1.5. And then we're gonna have it end here at 11.5. So then this is going to be our period, which we'll calculate later. But first, let's find the center for the vertical shift. So we know that our center here is going to be at -600. So that's going to be our vertical shift. We're going to have a vertical shift of C equals -600. Then to find our amplitude, we're going to find the distance from the center to the maximum point. So it's going to be from -600 to 200. And that's going to be -400, but it can just be positive because it doesn't matter which way it goes. So we're going to have that A is equal to 400. Oh, sorry. We're going to have that A is equal to 400. So we can find our phase shift D, which is the shift over from the x-axis. So we have from the x-axis here to right here. So that's going to be 1.5. So we have that our phase shift D here is equal to 1.5. And then we're going to have and then also just keep in mind that these equations are not unique. So there's different equations that you can make for, there's a lot of different equations that you can have that represent the same function. So then we can find the period here, which is equal to 2 pi over b. So we're going to set this equal to the end of the period minus the beginning. So up here, we have the end of the period being 11.5 and the beginning of the period being 1.5. So if we do 11.5 minus 1.5, we're going to then have 10. So then we're going to set here our 2 pi over b equal to 10 over 1. So if we then do the cross product, we're going to have this be 2 pi over 10, which is going to give us pi over 5 for the period. The period generally is going to be the same no matter which equation you make. So is the vertical shift and so is the amplitude. So now we have these values and we can plug them in to our sine function. So we're gonna have A, which is 400 times sine, or we don't need a parenthesis, times sine of B, which we found to be pi over 5 times x minus D, which is gonna be 1.5. And then we're gonna have plus C, which is a vertical shift. So we have -600 for that. So this can be one of our sine functions for it. Then we can do the same thing to find the cosine function using a different period, because the cosine function crosses the x-axis at a different point in time. So for the cosine function, we can actually start at the beginning, probably. So we would have from, let me find a different color. So we'll have from here, this can be the start of our cosine function. We'll have from here all the way over to here will be 1 period. So our period length is going to be the same because it's the same function. So our B is going to be the same. Our vertical shift is also going to be the same. our amplitude should also be the same because it's the same function. So the phase shift is what's going to be different. So to find the cosine function, we cannot start at 0 because we don't exactly know what the point 0 is, which we can also find that later. Instead, what we're going to do is we're going to start at the next point, which is here, this pink line right here, and we're going to go to the next line, which is right here. So we can start at 9 for finding the phase shift. If we go down here, we'll see that the center in the vertical shift is going to be the same. The amplitude will also be the same for the cosine function as it was for the sine function. And then the period B will also be the same. So what's going to be different here is the phase shift. So for the phase shift, what we did was we found the shift from the x-axis. So we can find that, the shift from the x-axis all the way to here, which is 9. So we're going to have 9 minus 0, and it's going to be 9. So instead, we're going to have A, which is also going to be 400 cosine of pi over 5 times x minus 9 minus 600. So question C asks us then to find at time t equals 0 when your ship was discovered by the enemy, how far below was the surface was your ship? So we know that this is at time t equals 0 here, so we have to value in this value. So in order to do that, we can also have, instead of this being x here, we can have it be t. So 400 of cosine of pi over 5 times t minus 9 minus 600. We can now plug in t equals 0 into this equation to find at what height the ship would have been at this time. So if we plug in t equals 0, we'll have 0 minus 9 times pi over 5, all being taken cosine of 400 minus 600. So if we continue to work this out, we'll have negative 9 pi over 5 minus 600 times 400. Then we can take the cosine of negative pi over 5, which would give us, we can do that in our calculator or with the unit circle, however you want to do, but then we would get for this negative 276.393 meters. So meters can't really be negative, so we can just take away the negative sign and make it positive, and we will have that our ship at time t equals 0 was at 276.393 meters below the surface. So question D asks, if when your submarine is safe when it is at least 300 meters below the surface, between what two positive times is your submarine first safe? So we need to figure out here when the submarine crosses, when the submarine comes down to negative 300, which is probably going to be sometime around here, and then comes back up to 300, which is probably going to be sometime around here. So we can find this by setting our sine or cosine equation equal to negative 300, because we are here changing the y value. So if we go down here and we set our cosine equation equal to, we set this equal to negative 300, we can now work backwards to solve and figure out what time this would be at. So in order to work backwards to solve, we're going to have to try to isolate cosine of alpha first. So we're going to add 600 to both sides, which is going to give us 400 cosine of alpha is equal to positive 300. And then we're going to divide by 400 from both sides. And we're going to have that cosine of alpha is going to be equal to 3/4. So we can look at the unit circle to figure out when cosine of alpha is equal to 3/4, and we can also Yeah, so we can find out when cosine of this is equal to 3/4. But the only thing is we still have other things going on inside of this alpha and inside of the cosine. So we're gonna have that our entirety of what's inside of alpha is gonna come here, and we're gonna set this equal to the inverse cosine of 3/4. And once again, we're gonna have our plus 2 pi k to represent any revolutions that would need to be made. And then we're gonna also have this equal to 2 pi minus cosine inverse of 3/4 plus 2 pi k. So we have the 2 minus here because we're looking for the first time that it goes to 300, and then we're also looking for the second time. So the second time is going to be represented by the 2 pi minus because 2 pi is going to be an entire period. So that's going to represent the ending point. So we go down here, we're going to do the same thing that we did in problem 1, and we're going to solve. So we're going to have that k is equal to 0 and k is equal to -1. And I won't go as in depth in this as I did earlier, but when k is equal to 0, t is going to be equal to 10.150 and 17.849. Because if we solve and we take out pi by multiplying by, what we do is we multiply both sides by 5 over pi, multiply this side by 5 over pi, and then we'll add 9 to both sides after we do that. And that will bring us here. Once we plug in k equals 0, we'll get these two values. And then for here, once we plug in k equals -1, we're going to get that t is going to be equal to 0.150 and 7.849 minutes. If you want to watch it, and if you don't want to, you don't have to. That alpha is equal to pi over 5 times t minus 9. So we had set it up like this here, based on the inverse cosine, and it being equal to 3/4, which we solved up here. So down here, what we're going to do is we're going to take the first equation, which is inverse cosine of 3/4 plus 2 pi k. And then the second equation, which is 2 pi minus cosine of -1 3/4 plus 2 pi k. And we're going to set them both equal to this pi over 5 times t minus 9. So in this first part here, what we're going to do is we're going to then multiply by 5 over pi. And then we're going to multiply also this side by 5 over pi. And then this is going to give us t minus 9 is equal to 5 pi inverse cosine of 3/4. Plus, and then these pi's are going to cancel, right? We're going to have 10k. And then here, we're going to do the same thing. We're going to multiply both sides by 5 over pi. And we're going to have t equals 9 is equal to 2. Oh, sorry, let me do this part first. We're going to have 5 over pi times 2 pi is going to give us 10. Just 10 because the pi's are going to cancel out. We're going to have 10 minus inverse cosine, or we're going to multiply, we're distributing. So we're going to have minus 5 pi inverse cosine of a -3/4 plus these pi's are going to cancel out once again, and we're going to get 10k. So the difference between these two right now is that this one has this 10 minus the entire equation, and this one is just the positive version. So what we're then going to do is add 9 to both sides. This is a minus sign, sorry. So then we're going to have 5 over pi cosine inverse of 3/4 plus 10k plus 9. And then on the side, we're going to have, on the side, we're going to have 19 minus 5 over pi inverse cosine of 3/4 plus 10k. So we can now use our calculators, or however you want to do it, unit circle, to find out what 3/4 is equal to. And then we can use our calculators to find the entire rest of this equation here. And then we will, after that, plug in k equals 0 and k equals 1. And you can also use your calculator for that part. And you can do that while you're plugging it into your calculator and then get those final answers that we got earlier. So comparing the two values that we got for k equals 0 and k equals -1, since we're looking for the first time that our submarine is safe, we're going to use the smaller values. So since these are the minimums, we're going to use these. So the first time our submarine is safe is going to be at time t equals 0.150, and then also until time 7.849 minutes. So this is our first range in which our submarine is going to be safe.